mathematics questions that have come in the past, and today we are going to deal with indices, the topic indices. We are going to have part 1, and then after some break we'll have part 2. Welcome. So let us start with some review of the topic. We start with the laws of indices. So that you can be able to handle those KCSE questions. Number 1, if you have a raised to m times a raised to n, the first law of indices, a raised to m times a raised to n gives us what? When you are multiplying common bases, what do you do to the powers? You write the base and then you add the powers. Number 2, if you have a raised to m, divide by a raised to n. Yes, common bases, you are dividing. What do you do with the powers? You write the base and then you subtract the powers. Okay? We go to number 3. If you have a raised to m and then it is raised to power n, Lana, what do you get? This normally gives us what? The base is a. Then what do you do with these two powers? You multiply. M times n gives you mn. Number 4. If you have a raised to 1 over n, a raised to 1 over n, this is the same as what? It is the same as n the root. You know, this denominator here, take it as a root. So it is the same as n the root of a. So you write n the root of a. Number 5. If you have a raised to m divided by n, Lana, this is the same as what? This is the same as this base, take it as a root, just like here, and this numerator, take it as a power. And therefore you talk of n the root of a raised to m. Yes, this the base, the denominator here, the denominator, take it as a root, the numerator is a power. So n the root of a raised to power m. Number 6, if you have a raised to a negative power, it is the same as what fraction? It is the same as a fraction 1 over the a, your number, raised to a positive power. The a raised to a positive power. And finally, if you have a raised to 0, that is any number raised to 0. Any number raised to 0 is 1. Any number raised to 0 is 1. And therefore, Lana, with that, let us go to KCSE problems and handle them. Number 1, solve for x in this equation here. It was carrying 3 marks in 1993. So solution, how do you go about it? You first take this constant to the other side. Take the constant to the other side. So 9x plus 3 raised to 2x is equals to 53 minus 1 becomes plus 1. So this is 9 raised to x plus 3 raised to 2x is equals to 54. From there, Lana, come to these two terms and express them using a common base, base 3. base 3. Common base 3. So 9 is the same as 3 squared. That is our 9. And then it is raised to x. Then plus our 3 raised to 2x, yes, which is equals to 54. 54. From there, learner, we have reminded ourselves about the laws of indices. 3 raised to 2, then raised to x is what? Here you multiply the powers according to the laws of indices. So you write 3 raised to 2 times x, 2x. Yes, plus 3 raised to 2x is equals to 54. Look at these two terms, they are the same. So you come and say, let 3 raised to 2x be y. Let it be y. Then come and substitute your y's here. This is y and this is y. This is y and this is y. So you talk of y plus y is equals to 54. Y plus y is 2y is equals to 54. And therefore to get y, you divide both sides by 2. So y is equals to what? 27. But we didn't want y, we wanted x. We were solving for x. So you come back here. Your y is 3 raised to 2x. So you come and write your y is 3 raised to 2x is therefore equals to 27. Then express these two using a common base, 3. So you write 3 raised to 2x is equals to 27 is 3 raised to what? 3 raised to 3. From there, look at the bases. The bases are the same on both ends of the equal to sign. Once the bases are the same, you equate the powers. And therefore, equating the powers, we will get 2x is equals to 3. Divide by 2, divide by 2, so that you get your x. And therefore, your x is equals to 3 over 2, which is the same as 1 whole and a half. 1 whole and a half. Yes, and that is that. We go to question number 2. So question number 2. Find the value of x in this equation here. Format, it was there in 1995. So what is the solution? What is the solution? What is the solution to this equation? So, learner, you come direct and get a common base for these two. And the common base would be 7. So this one would be what? 7 squared is your 49. And then this 7 squared is raised to x plus 1. It is raised to that power. Plus 7 raised to 2x is equals to 350. Come to this one and deal with the powers here. According to the laws of indices, you multiply these powers. So you'll have 7 raised to what? 2x plus 2. 2x plus 2. Plus 7 raised to 2x is equals to 350. Good. We go to the next step. Come to this term here and separate it through here. 2x plus 2. Separate it according to the laws of indices. We can write this as 7 raised to 2x times 7 raised to 2. Look at that, learner. 7 raised to 2x times 7 raised to 2. Common base, 7. Then you do what to the powers? You add. So this is the same as this, using the first law of indices. Plus 7 raised to 2x is equals to 350. Yes, Lana? So if you look at this now, you have 7 raised to 2x there and 7 raised to 2x there. A common term. Let it be y. So you come and write, let 7 raised to 2x be y. So where you have 7 raised to 2x, write y. Write y there. So you have y times 7 squared is 49 plus y is equals to 350. And therefore multiply out, this will be 49y plus y is equals to 350. This gives you 50y is equals to 350. Okay, divide both sides by 50 to get y, and therefore y will be equal to what? 7. But again, we don't want y, we want x. We are told find the value of x. So you come here, your y was what? 7 raised to 2x. So your y was 7 raised to 2x, which is therefore 7. 7 is raised to what? 7. Once you raise 7 like this, it means it is raised to power 1. Again, look at this learner. You have common base at the on the edge of the equal to sign. 7, 7. So once you have common bases, you equate the powers. 2x is equals to 1, and therefore divide by 2, divide by 2. Your x therefore is equals to a half. Your x is equals to a half. Good. Thank you, Lana. Let us meet for the second part of indices after some break. Good.